Let's look at this circuit. Which type of circuit is this? Is this a series or a parallel? Well, I've got these two resistors that are next to each other, that are each forming their own branch, so that's clearly parallel. But then I have this resistor up here that's just in the same line with these two together. That would be series. Is this a series or a parallel? Well, in fact, it's actually both. This is both a series and a parallel circuit. So we came up with a very clever name, series parallel, to describe this. And in order to investigate this type of circuit, which is extremely common among circuit analysis, that you're almost never going to encounter a circuit that is purely series or purely parallel. It will almost always be some combination of both, with the exception of the lighting in your home. But even that, at your breaker box, it gets put into series. So how do we investigate this? The way we're going to do this is we're going to break these up into a series portion and a parallel portion. As simple as that. So let's go ahead and make a variable list and just start to keep things in some kind of organized order. So I've got my voltage source, so we'll call that V total. I'm going to have some kind of total resistance. I'm going to have some kind of total current. So those are going to be my norms, just like I always have. But then I'm going to have my R1. We'll call this 1, 2, and 3. So we'll have R1, R2, R3. So let's label those right now. 1 is 50 ohms. R2 and R3 are both 100. And then what I'm going to need to do here is I'm going to need to figure out the total resistance for each section. So let's start with R2 and R3. The way we do this is we say that between R2 and R3, so R2 and 3, that'll be a parallel circuit. So we're going to find the resistance between those two the same way we would find it for any other parallel circuit. So R2 and 3 is 1 over R2 plus 1 over R3. And so 1 over 100 plus 1 over 100, and then 1 over that number, that'll get us 50 ohms. Okay? So then, the way we can think about this, in order to actually examine this circuit, what we're going to do is we're going to mentally redraw this. Now I'm going to redraw this on here so that we can kind of see what I'm saying. So I've got R1, and that's in series with resistors 2 and 3. So I'm going to need to take the total resistance between these two, which was 50 ohms, and treat that like it's in series with resistor 1. So I could really redraw this circuit and go like this. And call this R1, and call this R2 and 3. And then this becomes 50 ohms, and this becomes 50 ohms. And then I just run everything by series circuit analysis rules. So according to series circuit analysis, I would add up my resistors to get a total resistance. So 50 plus 50, that's going to be 100. So my R total is 100 ohms. So there we go. So when we're examining the resistance in a series parallel circuit, what we need to do is figure out which parts are series and which parts are parallel, and then add those together. Once I've done that, everything proceeds just like normal. So I've now got a total resistance of 100 ohms. I already had a total voltage of 100 volts. And so Ohm's law is V equals IR. So in order to find current, I'm going to take voltage divided by resistance, 100 divided by 100. That will be 1 amp. Okay. So then, let's take this a step further. Let's say, what is going to be my voltage at R1, voltage at R2, voltage at R3, then what's going to be the current at each of those as well? So in this case, The biggest part, if I redraw this with just two resistors until I only have a series or only a parallel, then what I end up with is a series. So the first rules that I'm going to apply are going to be series circuit rules. So we're really working from the biggest picture down to the smallest picture. So what I mean by that is before either of these two resistors would see a voltage, that voltage is going to get used up by this resistor first. And that is going to get used up according to this redrawn circuit. So in order to find the voltage at R1, I'm just going to use the regular series circuit voltage rules. And that's going to be V total is going to be equal to V at R1 plus V at Rs 2 and 3. So those two combined, remember, these are going to be in parallel. They'll see the same voltage, but they won't see the same voltage as this one right here. So 50 and 50 here. So these are each going to be 50 ohms. And then together they're going to make 100 volts. Well, these are pretty simple numbers, so we should be able to see these without any of the calculations. I've got 100 volts total. These have the same amount of resistance, so obviously this is going to have to be 50 volts. And then at VR2 and 3, it's also going to be 50 volts. You'll find it helpful to denote these little sums of the different parts of the circuit, totaling up your resistance to treat it as its own separate component, because that'll help as we break this down further. So I'm also going to put one of those right here. So then what's my current going to be at R1 and R2 through 3? Well, that's going to follow series rules as well, which means it's going to be the same as the total. So this is going to be 1 amp, and this is going to be 1 amp. Now that I have that, I can treat this part, let's use a different color, I can treat this part as a parallel circuit with this as my total voltage and my total current. That's why we broke these variables up this way. So now, voltage, 50 volts, according to parallel circuit rules, it's going to be the same voltage at each resistor. So these are going to be 50 volts as well. And then the current is going to have to divide up according to the parallel circuit rule of I total equals I R1 plus I R2, and so on and so forth. In this case, it's going to be R2 and R3. Now, because R2 and R3 are both the same resistance, we're just going to divide it by 2. It'll just divide in half, be nice and even. So each of these will be 0.5 amps. So that's the whole circuit analysis for this. Let's look at another circuit that actually works in the opposite direction, where the series is the more detailed portion and the parallel is the bigger picture portion. Okay, we've got this circuit set up here. In this case, we're working in the opposite direction. I have two resistors in series that are both together in parallel with this first resistor. So let's write out our variable list and let's investigate it. Now, just like in the last one, we're going to need to split this into a summation of our series resistors. So I'm going to go ahead and do that right away this time. And I recommend, as you go through these different types of circuits, these series parallel circuits, identify the portions of the circuit that are one and only one type of series or parallel, and then total up those as their own variable so that you can use that later on. So in this case, it's 2 and 3, so it's going to be R2-3, 2 through 3. Okay, now I've intentionally used simplistic numbers for our resistances so that we can just see the patterns rather than have to do any complex calculations. So the first thing I want to do is I want to put all of the numbers that I have into my variable list. Total voltage, 100 volts, R1, 100 ohms, 250, R3, 50. Next, I want to find my total resistance. I know the resistance of each resistor. I should be able to figure out the total resistance so that I can solve the rest of this circuit nice and easily using Ohm's law. First, my R2 and R3 are in series together. I cannot add either of these together with R1 directly. First, I need to figure out the total between them, which is R2 and 3. Fortunately, the series rule for resistors is very easy. It's just R total equals R1 plus R2, so on and so forth. So it's just going to be these two added together. So 50 plus 50 is 100 ohms. And now, to get R total for this whole circuit, let's redraw this again so that we can imagine it the right way. So there we go. We've redrawn it, merging these two together, because according to the parallel parts of the circuit, it doesn't matter that these are separate resistors. We can treat them as one thing. So the resistance at 1 is 100 ohms. The resistance at 2-3 is also 100 ohms. So according to parallel circuit rules, that would be R total equals 1 over R1 plus 1 over R2, so on and so forth. So 1 over R1 plus 1 over R2, when we have 100 for each of them, is going to be 50 ohms. So my total here is going to be 50 ohms. All right? And now I should be able to figure out my total current, and then I should be able to figure out all of these variables down here. Total current is found using Ohm's law. That's V equals IR. It's going to be 100 divided by 50, which is 2 amps. Now, because my biggest picture, that is with the fewest details, the fewest resistors, everything is merged together as best as it can be, since this is a parallel circuit, the first thing we're going to do is follow parallel circuit rules. Parallel circuit rules says that V total is equal to V1 equals V2. It splits up evenly. They don't get divided up. It is all going to be the same. These are going to see the same voltage. So my V total was 100 volts. So my voltage at R1 is 100 volts. And my voltage at R2 and 3 is 100 volts. Okay. And then the other rule for parallel circuits is total current, which is going to be IR1 plus IR2, so on and so forth. If I had R3, it'd be plus R3 in there. So my total current was 2 amps. My resistances are 100 and 100, so they're even. So this is going to split up evenly. So 2 divided by 2 is going to be 1 amp. There we go. Now, if we took this and confirmed it using Ohm's law, I would have voltage divided by resistance would equal current. Voltage divided by resistance would equal current. So now we just need to figure out VR2, VR3, IR2, and IR3. Those are going to follow the series circuit rules, which is V total equals VR1 plus VR2, and I total equals IR1 plus IR2, so on and so forth. Or I'm sorry, not plus, equals. So my current here at R2 and R3 will be equal to the total current that is hitting that branch. So the total current that these two resistors see is the current that is going through this branch. Okay? It is not the current over here. They see this current, not that current. So this current is 1 amp. They will each see that. Now, our voltage, we could find it easily using Ohm's law or using this rule. Either way, we'll find that 100 volts going to R2 and 3 is splitting up between two 50 ohm resistors. So it's being split in two because my total resistance here is 100. 50 divided by 100 is half. So we're going to get 50 volts at each resistor. Very good.